statistics is fantastic. Hi, this is Teacher Rosaline and welcome to our statistics class. What do you think is the magic word behind the pictures? We have the picture of a family, a magical picture of friendship, a picture of a teacher with her students, and the two girls with their classmates. It starts with letter R. Fantastic! That is relationship. Do you have a good relationship to your family, to your friends, to your teachers, to your classmates, and to the other people around you? Yes, you need to maintain a good relationship with others for a healthy and happier life. Research studies deal with the relationships between two or more variables. Statistics offer different variety of tools and techniques needed in making such studies. One of these is the correlation analysis, which is specifically used to measure the nature of relationship. Take note, relationship between variables.
Correlation. The term correlation is a combination of two words. Co means together and relation means connection. Correlation is done at the time of study of two variables. The unit change in one variable is reacted by an equivalent change in one variable, directly or indirectly. And the variables are served to be uncorrelated when the moment in one variable does not show any moment with another variable in a specific direction. It is a statistical technique which represents the strength of connection between the variables. Correlation can be positive or negative. When the two variables moving the same direction, that is increasing in one variable with an increasing of the other variable or vice versa, then the variables are considered positively correlated. For example, profit and investment. On the contrary, when the two variables moving different direction in such a way that an increasing in one variable and a decreasing one variable and vice versa, this situation is known as negative correlation. For example, price and demand of a product. The correlation coefficient doesn't just tell us whether the two variables move in the same or opposite direction. It also indicates how strong the relationship is, and its value ranges from -1 to +1. As 1 indicates the perfect or strongest positive correlation, and if I pay you $20 for every apple you pick, the correlation coefficient between the number of apples you pick and your apple picking earnings for that day would be 1. B. -1. It indicates the strongest negative correlation. To use the previous example, if I start the day with a large pile of money from which I pay you, the correlation coefficient between the number of apples you pick and the amount of money on my pile would be -1. C. 0. It indicates that there's no correlation at all. And the most popular formula is the Pearson product moment correlation, which is represented by the letter R. There is also the range of values of Pearson's R, from 0, that there is no correlation, up to positive or -1, for perfect positive or negative correlation.
Now, let's apply calculating correlation coefficient. This coefficient is easily calculated using the Microsoft Excel, and you can use also the formula and compute it manually. For method 1, for example, the temperature of the day versus the ice cream sales. To determine the correlation between the two variables, use the function correl. Type the function correl and select the first column and type comma. After that, highlight the second column. We will get the value of correlation coefficient, and that is 0.96. It means that there is a strong relationship between variables.
Another example. Calculate the correlation between mathematics and physics for 10 students whose scores appeared in the table.
So we will use the Microsoft Excel. So you must have your data on the first and second column, and then use the function equals and correl, open parenthesis, and highlight the first column, comma, and highlight the second column, and then close parenthesis. Then enter. So you have now the value of correlation, and that is negative 0.36. It's so easy, right? So we can now interpret negative 0.36 using the range of values of R. That is low negative correlation. Calculating correlation coefficient using the formula and a manual computation. Using the same example, calculate the correlation between the mathematics and physics for 10 students whose scores appeared in the table. So we have the complete table. For the first column, we have the students. For the second column, we have the column of math scores. And for the third column, we have the physics scores. And we have already the summation of our math, or the X, and the summation of physics, or the Y, which is 103. So we are going to complete for the X squared column. For 9, we get that from the column of X, that is 3 squared. Next, 49 is from 7, because 7 squared is 49, and so on. So the summation of X squared is 385. And for the column of Y squared, we have 121 from 11 squared. And we have 361, and so on. And the summation of Y squared is 1401. And the column of XY, the 33 is from X times Y, that is 3 times 11, we have 33. 7 times 1 is 7, 2 times 19 is 38, and so on. And the summation of XY is 506.
Since we have already the data that we needed, the summation for every column, and the sample size, we can now apply our formula R equals N, or the sample size, times the summation of xy minus the summation of x times summation of y divided by the square root of sample size, or n, times the summation of x squared minus summation of x squared times n, or the sample size, times the summation of y squared minus the summation of y squared, where x is the observed data for the independent variable, y is the observed data for the dependent variable, n is the sample size, and r is the degree of relationship between x and y. And we can now substitute the values to the formula r equals n, which is 10, times the summation of xy, which is 506, minus the summation of x, which is 55, times the summation of y, which is 103, divided by the square root of, take note to extend the square root because that is included, n, which is 10, times the summation of x squared, which is 385, minus the summation of x, which is 55, squared, times the sample size, which is 10, times the summation of y squared, which is 1401, minus the summation of y, which is 103 squared. After substituting the values, we can now apply the operations. So, 10 times 506, that is 5060, minus 55 times 103, that is 5665. divided by the square root of 10 times 385, that is 3,850, minus the 55 squared, that is 3,025, times 10 times 1,401, that is 14,010, minus 103 squared, that is 10,609. And now we have 5,060 minus 5,665, that is negative 605, divided by 3,850 minus 3,025, we have 825, times 14,010 minus 10,609, that is 3,401, and the correlation is negative 0.36. We have now the value negative 0.36, that is the correlation coefficient. We can now interpret using the range of values of Pearson's R. And negative 0.36 is located on the range 0.31 to 0.50. And the correlation obtained was negative 0.36, showing us that there is a low negative correlation between mathematics and physics. We have the same answer using the Excel and a manual computation, right? Now, it's your turn on page 123. What's more, calculate the relationship of scores on 20-point English and math quizzes of 5 students. Complete the table first. We have the first column of students, second column the English are denoted by X, the third column is the math are denoted by Y, and complete the column of X squared, followed by the Y squared. And for the last column, we have the XY column. And complete all the summation for every column. You will use the formula of Pearson's R, and you can check your answers using the Excel.
That's all for today, and I hope you have learned a lot. Again, this is Teacher Rosalyn saying, there is a positive correlation between learning and success. Bye-bye! See you next lesson!